But I'd like to introduce Dr. Zhou. I've had the pleasure of working with him for at least 5, 6, 7 years or more. He's got his PhD from UC Berkeley and is an epidemiologist who's worked in many federal agencies for well over 15 years and is currently with the U.S. Department of Energy Office of Environment, Health, Safety, and Security. So his talk today will be Reanalysis of Radiation and Mesothelioma in the U.S. Transuranium and Uranium Registries. You did a nice job there, Joe.
Thank you, Carl. Yeah, just before the conference, I twisted my ankle playing basketball, so it took me some time. Well, let me start by congratulating Sergey, Maya, Sarah, George for wonderful presentations. You should be proud of yourself. You know, for my, it's tricky, my presentation, I don't know, we break up a session into internal and collaborative research. So I'm happy you put me in the internal. So consider me one of you. And I know I bother you too much, you cannot keep distance from me. Okay, so as Carl says, as a program manager, I work DOE USTUR manager for 8 years. Personally, I'm really appreciative of working with the USTUR staff, the team. And, you know, I learned, again, I'm trained as an epidemiologist. You know, to manage this program was challenging initially. I learned so much from USTUR team, you know, health physics, dosimetry, kinetic modeling. So I'm really thankful for them. So please allow me to take a moment to recognize the compassion and the dedication of USTUR's staff, current staff, to carry on the tradition, the great tradition of 50 years of USTUR, the great list. Let's give them a round of applause. Okay, so this presentation is about reanalysis of radiation and mesothelioma in the USTUR. Let's just put this one.
You could do either. You can,
I need a laser later. So
okay, laser's right there. And
okay. Thank you. So it has been noticed for a long time that there's excess of mesothelioma deaths in the USTUR. Gold and Catherine, Ron Catherine was sitting here, published in 1998, reporting that there are 6 mesothelioma cases. So basically it says in the abstract, in general, no apparent elevated causes of death except for 6 cases of mesothelioma. The mesothelioma cases had a documented occupational exposure to asbestos. So in 2013, Gibb and his co-authors published a paper, Analysis of Radiation and Mesothelioma in the USTUR. At that time, 1 more cases was added, so there's 7 mesothelioma cases among 329 disease registered. So this study basically using the proportional mortality ratio. It's interesting that earlier Ron talked about this controversy in 40 years ago in the 1970s, about the similar studies, epi studies. It's just interesting that after a long history, then the things can repeat himself. So basically, the study compares percentage of causes of deaths between USTUR and the general population in the US, and it suggests that external radiation at the nuclear facilities is associated with an increased risk of mesothelioma. So Ron touched this a little bit. So basically, if we have small number of cases, it's troublesome to do a proportional mortality analysis when you have a small size. Plus, USTUR we know is self-selected, it's volunteer-based. So any conclusion you have for the study is not appropriate to make inference to general population. Okay, so but this presentation I'm not talking about that. There's errors made in the study. I only can talk a little bit. So basically, the study failed to recognize that the software they use for the analysis cannot do the appropriate comparison because there's no data of mesothelioma before 1999. So the mesothelioma only coded, have a specific code in the ICD-10. So before 1999, they don't have specific code for mesothelioma. The software did not take that into consideration. So only, of course, the manual says indicate that. So we know, we mentioned earlier, 6 of 7 mesothelioma cases were before 1999. So from early on, the study made an error. So the analysis on the mesothelioma radiation was wrong. So I submitted a letter to editor about this, and also I presented a talk 2 years ago at Health Physics Conference in Baltimore 2 years ago. So now we think about the reanalysis of the data. The previous approach obviously is not going to work. So what we can do with the data? So we know that there's excess of mesothelioma cases in the USTUR. Actually, we have 2 more cases now, so a total of 9 cases. And we now have 341 deceased registered. And we also know the mean cumulative external radiation dose is higher for mesothelioma group than other groups like cancer and lung cancers. That's how they initiated the study at the first place, the initial studies. So what I'm going to do is just focus only compare the group means. So just see if the mean difference are significant or not. So this is a table. So we break up the cases registered into 4 groups: mesothelioma, lung cancer. I'm going to see if I can use this. Lung cancer, other cancer, and the lung cancer. So we know we have 9 cases for mesothelioma. So we have 31 lung cancer and so forth. So if you break up by the demographics or characteristics, so you know that first of all, as I said, the mean exposure is higher than other group. It's 173. Others, the question is it significant or not? So we know the employment duration is older, the longer, and the employment start is earlier, and the age of death is older. So obviously, the group in mesothelioma is different from other groups. So that means that indicates that the age of death, employment start, and employment duration are potential factors associated with cumulative external radiation exposure, the dose. Be careful on the dose and exposure. The take-home message is we need control. So make sure that the groups are comparable. So we use the match case control approach. So basically, we match each case with these factors, these 4 factors: employment duration, employment start, age of death, at death, birth year, and so then you calculate mean exposure again. So this is before and after matching. So you see that lung cancer group, after matching, is just higher, so it's more closer to the mesothelioma case group. And the other cancer group, actually higher, but the difference is still smaller. And the lung cancer group, actually, the difference is a little bit bigger, become a little bigger. So and I'm going to focus on the mesothelioma and the lung cancer group. For the next slide. So this is just, as an example, just compare the mesothelioma group and lung cancer group. So again, for each case, this is the case, number 1, number 9, mesothelioma case. For each case, we match by those factors. So for the case 1, we have four controls, and for example, case number 8, we have 5 controls. So then we use a paired t-test. But we have a small sample, so I have to use t-test, and also because of assumptions, the distribution issues. So I use this more maybe robust, robust approach. So using the simulation permutation test. So basically, for each paired t-test, I can choose any. I'm sorry. So for each t-test, I randomly select, the control group for, pick 1, and the number 2 pick 1, randomly. So you can do many t-tests. So the criteria is to tell is significant or not is, say, for example, 5%. If 5%, test showing significant, I say, well, which is maybe this is a significant. So do this 10,000 times. You could do a permutation test. You have so many combinations. You can have 300,000 combinations. So obviously you don't want to do that. You just choose randomly for 10,000 times. We get a stable result. So the results show actually there is 9% of tests showing significant t-test. But if we do using this for mesothelioma group and the lung cancer, so no significant test. And the meso with other cancers, you have very few significant tests. So the focus actually is just for the mesothelioma group and the lung cancer. It's not like a 20%, 30% significant. It's a little bit elevated, a little bit more, or if you call it marginal, it's 9%. So the conclusion is that the mean cumulative external radiation dose in mesothelioma group is statistically higher than lung cancer group. I don't have time to talk about this, but the conventional follow-up analysis, the modeling will be, to see this association between the mesothelioma dose and the exposure and the mesothelioma cases. So the follow-up conditional logistic regression for the mesothelioma and the lung cancer group shows no association between external radiation and the mesothelioma. And by the way, so the reanalysis make no inference about the U.S. nuclear workers, unlike the initial study by Gabe et al. So because the USTUR registrants are not representative of nuclear workers. So to end my presentation, I want to have this key point emphasis. in light of the celebration 50 years, I just want to quote from the history, earlier, conclusions. It is to be emphasized that present USTR, at that time, US is called US Transuranium Registry. USTR is not an epidemiological study. The USTR does not seek to measure mortality rate for specific disease in transuranium workers. The use of USTR data for this purpose is scientifically inappropriate and misleading. Thank you. Yeah.
We are a little ahead of schedule, so if anyone has questions.
First of all, I want to thank Joey for extending the work that we did. And I do point out that history repeats itself. As Clarence Darrow said, that's one of the troubles with history. The proportionate mortality that was used by Sidney Wolfe and Gibbs show the dangers of coming up with erroneous conclusions. Now, Wolfe's wasn't so bad because it was not published in the peer-reviewed scientific literature. So here we have a paper by Gibb in the scientific literature that if you want to make an issue in certain ways, you can use. The second thing, and I'm going to pat the operational health physics people on the back now, the higher radiation dose in those earlier cases, I think, is indicative of the fact that people early on were permitted higher doses, and in later years, the the exposures were in fact reduced. So I think that's a tribute to the people who set the standards, but an even bigger tribute to my colleagues who are in operational health physics. And if any of you are here, I salute you, and if you're not here, I hope to see you at the Academy luncheon.
Thank you.